on work and power. And these are going to be really short, but we're going to learn 2 more math equations and then just do a lot of practice with all of the different equations we learned, because this is definitely our most math-heavy unit. I mean, I guess the first one too, but this one a lot. So let's make sure you're awesome at it. First, though, we need to know what work is. So my first question for you is, have you done any work today? Now, I'm not sure what your answer is, but it may not be the physical science, or the physics, I guess I should say, definition of work. And that is the transfer of energy that occurs when a force makes an object move. In an equation, it's abbreviated as a W. It's measured in joules because it's a transfer of energy, and anything related to energy is going to be measured in joules. And 2 things are important. 2 things have to be true in order for work to be done. The object must move, and a force must be applied in the direction of the movement. So, if this person is just standing here holding these books, it doesn't matter how heavy they are. Even though, yes, they're applying a force to keep the books up in the air, if they're not moving the books, then no work is being done. They would have to be lifting the books up and down or something like that in order for it to be considered to have done work. We can summarize this as an equation, and it's a nice and simple one. Work equals force times distance. So the W is for work, and again, it's measured in joules. F is force, and hopefully you remember from our force unit that it's measured in newtons. And then D stands for distance, and it's going to be measured in meters. So, example, you move a 75 kilogram refrigerator 35 meters. This requires a force of 90 newtons. How much work in joules was done while moving the refrigerator? Now, this is such an easy question that I just threw in an extra number just to see if it threw you off. So just see if you could figure out which numbers you actually needed. So let's think about it. Mass is 75 kilograms, 35 meters is a distance, and 90 newtons is a force. I'm looking for work. Well, work equals force times distance, so I don't even need that mass measurement. So I'm just going to plug in. My F is 90 and my D is 35. Multiply, and you should get 3,150 joules. Again, not bad at all. Everyone should be able to rearrange this equation very easily to do these 4 problems. So try these and pause, and then we'll go over them. All right, last thing and last equation. I told you this was a short one. It is power. And power, represented by a capital P, is the amount of work done in a certain time. Or you could say it's the rate at which work is done. To find it, it is going to be work divided by time. So that P stands for power, and that is going to be measured in joules per second, because joules is my work unit, time is going to be in seconds, so joules per second. Or you can use a special unit, which is watts. So 1 joule per second is equal to 1 watt. So you can always give your power units in watts or in joules per second. And you've probably seen watts on light bulbs and other different things like that. And it's referring to how much power something has. That W again stands for work, and that's measured in joules. And then T stands for time, and it's measured in seconds. So for example, it took 150 seconds to move a refrigerator. You did 3,150 joules of work in the process. How much power was required to move the refrigerator? So, 150 seconds is the time, 3,150 joules of work, and I'm looking for power. Power equals work divided by time. What I'm looking for is already by itself, so I can just plug in and solve. So that's 3,150 divided by 150. And you should get 21, and remember that could be joules per second or 21 watts. Both are totally correct. All right, I told you, shortest notes ever. Now we are going to practice.